This is a lesson on the application of sinusoidal functions. Now this is a big part of the unit, so you have to get really good at it. And the idea goes something like this, that in terms of these applications, that many natural phenomena have a sinusoidal pattern. And we're going to look at a few examples, and then there are others in the book and a variety of places that you have to contend with. But they all basically work the same way. So once you master one, you're usually okay for anything else that comes your way. Tides are a really common one, and specifically it would be like the height or the depth of water at a dock at a certain time, and they do follow a sinusoidal pattern. Current and voltage is a very common one. If you've taken any physics or electricity, you'll know that they follow a regular, recurring, periodic pattern, which would mean that it would be sinusoidal. Times of sunrises and sunset also very, very common. So because they follow a 365-day pattern, they repeat themselves in that form, and then if you graph the sunrises throughout a year, you would get something that looked like a sine wave. Ferris wheels are pretty common too. Well, not the sort of thing you would use too much, but for some reason they show up in exams quite a bit, so you need to view them. They're good examples. And that would be based on the idea that as the time passes, the height of a rider will follow this sine wave because they're going in a circular pattern. But if you just charted it over time, of course your height keeps following this pattern over and over again, even though you're going through that circle. Now, in general, when you're dealing with applications of sinusoidal functions, we do a few things to start off. And that is we set our calculator to rad mode because all the applications are done in rads. The other thing to watch out for, not a big deal, but you need to be aware of it, is that the x-axis has to be converted to the appropriate time unit, usually time unit. But normally when you're graphing sine and cosine waves, you're dealing with degrees or rads. And here you have to convert it to something else, and usually hours or seconds. But it could be days as well, whatever. So this is what it's going to look like. The height being on the y-axis and the time being on the x-axis. A very common illustration anyways. So to get used to that conversion, let's start by finding an equation of the following graph. H at t, the height, is the y-axis, then the time is in seconds on the x-axis. You don't have a lot of information with this one, but we do have enough that we should be able to find this in its easiest form as a cosine curve. Because we're starting, the crest is right on the y-axis, this means that there is no horizontal translation, so therefore no c value. And also you can tell by inspection, I hope, that this graph does not have a vertical translation. We are centered right at the origin, or right at the x-axis, so it's symmetric about the x-axis. So therefore the amplitude, which is measured from the x-axis to the top, the amplitude will be equal to 6, and therefore A is equal to 6. Amplitude is always equal to A, or the absolute value of A. But the trick for us is to be able to find the B value. And to find the B value, we do note that the period is going to be crest to crest. And that being the case, we can see by inspection that the period is equal to 50 seconds. We need to include that seconds when we're dealing with the period, because the period in these applications refers to how long it takes to cycle. And don't just say 50, say 50 seconds. Once you get that, then it's just a matter of finding out what the B value is, and the B value, as I hope you know by now, is equal to 2 pi divided by the period. So the B value will be equal to 2 pi divided by the period of 50 seconds. And I'll just write that as 50, not put the units in it for the calculation. So B is equal to pi over 25. Another quirk of these application graphs is that we very often have a pi built right into the equation. And the purpose of that is to cancel out the pi and the 2 pi. And this means our formula h at t is equal to 6 cosine pi over 25 t in its simplest form. Of course, we could use a sine wave or a negative. We have lots of choices, but that we'll worry more about that later on. Slightly more complicated one. Find the period and amplitude of h at t is equal to 9 psi pi over 8t plus 1, and then sketch it. Now the amplitude is equal to the absolute value of a, so that means that the amplitude or the a value is going to be equal to 9. Period, a little more work. The period is equal to 2 pi over b. And the b value, as you can see, you've got that pi over 8 built right into it. So the period is therefore going to be 2 pi over 8. I won't show the step on this one, but when you divide that out, you multiply by the reciprocal of pi over 8, and you'll get 16. And because there was not a specific time unit associated with this, I'll just say 16 time units. Could be seconds, could be hours, whatever. So we have that information, but now we want to sketch this. And we will enter it into our calculator, and the key is to get that window setting down where you want it. And if you press window, you go into your X minimum, and I know you've seen this before, but I will write this out. We're in rad mode, remember. I would recommend making the X minimum the negative period, so negative 16. The X maximum, well, the X maximum is the positive period, so that would be positive 16. Now remember, these are not absolute things, but they do work really well. And if you have to adjust it later on, then you can do so. The X scale, I like to use the quarter, so I would just go 16 divided by 4. Now, of course, you could just enter that as 4, doesn't matter, but your calculator, if it's a more complicated period, your calculator will do it for you, which is the best approach. Now, the Y min and the Y max, you have to sort of use reasoning power with this one. We have a vertical translation of 1 unit and then an amplitude of 9. So our maximum value would be 10. So I like to give myself a little headroom. So for the Y maximum, maybe I'll go 12, although lots of numbers would work. The Y minimum, we should maybe do negative 10 so that we can see the entire graph with space. And then the Y scale, you could either go 1 or you could go 5. It's not going to make an awful lot of difference. But by doing it in this form, we end up with a graph that's going to fill the screen, which is really what we want. And you should get a graph looking, somewhat like that. And if you were to consider where that the d value is, d is equal to 1, so you can see that your graph is really, really, really just centered right around there. So now we have it sketched. Let's take a look at another one. Here we have the equation relating household voltage, V, to time is given by V is equal to 155 sine 120 pi t, where t is time in seconds. So those of you who have taken some electricity will know that you do get a real fast cycle rate on voltage and current for alternating current. Now, the question will begin with finding the period, the amplitude, and then sketching. So your period and your amplitude, we find them the same old way. I'm going to get the amplitude first. The amplitude is equal to the absolute value of A, if you want to write that, which is equal to 155. The period, well, this is equal to 2 pi divided by B So that means it's going to be equal to 2 pi divided by 120 pi. So therefore the period is equal to 1/60th of a second. So it cycles 60 times every second. Now you could find the quarter, or you could let your calculator take care of it for you, but it would be 1/60 times 1/4, which is equal to 1/240th of a second. And remember, the period really, or the quarter, really just has use in terms of it being a good sort of when we're entering our window setting. We do now deal with the window setting. The x minimum, if you go negative period, is equal to -1 divided by 60. The x maximum is positive 1 divided by 60. Your calculator will, of course, decimalize it, but don't worry. The x scale, I would go 1 divided by 60 on my calculator, and then just go divided by 4 and let it do it for you. And again, it'll turn it into a terrible decimal, but it doesn't really matter. The y minimum, because we're going from 155 up and down, we better give ourselves some space. So I'm going to go -170, and then I'll go +170 for the y max. And then the y scale, well, that's a little tougher to know. I'm going to just set it up at 10. Enter it in like this. y1 is equal to 155 sine 120 pi. Don't forget that pi. And for t, of course, you enter x. And then you get a graph looking like this. Now your scale won't show up quite as cleanly as mine did, but that's the idea with it. And even though this thing has been really, really severely compressed horizontally, you can't tell by the graph because you're basically just getting one cycle in it. So setting the windows properly manually is a great thing. Now the question I'm basing this one is going to be to find the voltage when t is equal to 6.0 times 10 to the -3 seconds. Now I'm not going to bring up the calculator for this one. I'm going to use my calculator to solve it, and you could actually just plug this value into the equation if you want it, but I'm going to use the graph. So that means I'm going to use what they call the value key. The value key, it's not really a key, although you can access it another way, but the easiest way is just to press trace. So when you have your graph up, press trace, and then you just press or you key in the number 6.0, 10 to the -3. Now make sure you use your scientific notation key. So that would be 6 and then EE. I know you don't need this, but I'll do it anyways. And then -3, and press enter. And what it does, when you know the x value, by using your value key, you can always find the corresponding y value. And you should get y coming up to be 119.4, which would be in volts then. So when you know the x and you're trying to find the y, and you've got the graph on your calculator, the best thing to do is just to use this key. So that's a quick look at these. The next lesson will have some more examples, but this will get you through most of them. So thank you for your time.